Building ETL pipelines in the cloud with Abdullah Bin Aftab. Hi. Hi, how are you? Hello.
Hey Damian, how are you?
Doing well. We were just talking, so it's weird to be like, "Oh, hey, we just met." So
Yeah,
welcome, folks, to those of you who may be tuning in live or watching us afterward. For us, we're recording it early Wednesday morning US time and late Wednesday evening Abdullah's time. So Abdullah joins us from Pakistan. He is an AWS cloud captain. He's a Postman student expert. He is leading the way in terms of technology evangelism and expertise in Pakistan. And I think our first Pakistani guest, which is pretty amazing. So thank you for coming on the show and thank you for joining us, Abdullah. Yes. Sorry.
so thank you so much, Damian. Thanks so much for having me, and it's a great opportunity for me, to speak up at this, in this channel, the vBrownBag, and thank you so much. So I'm really grateful to have you, have this podcast, and I would love to share my experience.
Yes, absolutely. Thank you very much. I'm really glad to have you here. So, tell me a little bit about what inspired you to want to talk about building ETL pipelines in the cloud.
Okay, so the thing is, when I was, learning some tech stuff, so there's no much resources to learn about the data engineering, right? So
Hmm.
people are more focused. If we are seeing 2 years ago, people were more focused in web engineering, web development, Android development, app development, right? So there's no that kind of AI thing. So, but the data engineering thing has been there like since decades, right? But
Hmm.
there are not so much resources. So this is what I have faced. So this is now I've taken an initiative. The which platform that I see, I'm gonna speak about the ETL pipeline, the data engineering stuff, so student or people would know that this thing literally exists. And in the now era of AI, machine learning, data science stuff, how important the data engineering is. So this is my real initiative.
That makes sense. That's very cool. That's awesome. I learned a little bit about. I took a small certification last year about it was data management with Microsoft Azure, and
Hmm.
I learned enough to know that that was not my thing. I was so I guess one of the good things about maturing as one grows is
Mm,
realizing what is your thing and what is not your thing, right? Like
yeah.
what you are good or not good at, and so yeah, that
Hmm.
was that was definitely one of mine, but I passed the certification. So that said, I'm actually really interested in hearing more about this. Studying for certification is very different than a real world
Mhm.
application of a technology. So I'm
Yeah.
I'm very interested. And if you're ready to go, we can go ahead and jump right into the presentation.
Perfect. Perfect. So, welcome everyone in the educational podcast in the building ETL pipelines in the cloud. My name is Abdullah Bin Aftab, and if you can see my screen, so let me just introduce myself briefly. So, by profession, I'm a data engineer, and I've been working with a lot of companies, a lot of startups. Right now, I'm working as a consultant. Also, I've done 3 certifications on AWS and 1 certification on Azure, and I think I'm capable enough to teach you the cloud stuff. Okay, so also if I'm talking about my community experience, so I'm a AWS Cloud Club region captain. Also, I have some contributions in Microsoft community, in Postman, also some other stuff. But right now, I'm focusing on in building AWS Cloud Club environment in my country. So, and yeah, as you can see, all of my pictures, these are my little contributions among the students. Okay, so we have a very beautiful agenda today. We are going to have a complete high level overview about the data engineering, about the pipelines, how uh, how things works in the back end, because we have just seen AI, machine learning models, but we don't know how where the data comes from, how the data would be prepared, right? So this is the part where you can actually have the good data, or clean data, where you can see a good applications of AI. Okay, so what we have agenda. So we are going to see what is data engineering, which is very important thing before learning the ETL pipeline, and we are going to see why data engineering is so important nowadays, and the dilemma, data science versus data engineering, because that's the most, most hype question. Peer students were asking me, hey, what's the difference between data science and data engineering? A lot of people confuse, a lot of people have thought that these are the same things, right? So these are the completely different things, and I have a very beautiful diagram to show you what's the difference between data engineering and data science. Okay, and then we are jumping into the what is an ETL pipeline. Then we can see building ETL in the cloud, conceptual flow. So basically, a lot of people would ask, have a question in mind, why on cloud? Why we cannot make on the on premise, right? So I have a very beautiful table to show you why things should be work on cloud and when you should take things on premise. Also, we have an AWS ETL architectures for you. And there's one thing I miss in the agenda, but I have something in my slides, the different paradigms of the pipeline, because there's ETL and the other one is ELT. Also, we have a little bit, a comparison of our data warehouse on AWS. So yeah, it's a complete good package. So I'm really excited to, just share my experience with you. And last but not the least, we have a closing remarks and we have a session for Q&A. Okay.
Awesome.
l- yeah, let's move forward.
Mhm.
Okay, so what is data engineering? In the simple answer is, it is a data collection, data storage, and data management. This is what data engineering is. But itself, these three words are the collection, storage, and the management are are really a big word. Like collection itself is a big word, storage is a big word, and management it's another word. You can see these are the planets which are revolving around the data. So when I say the data collection, it means, see, we have a lot of softwares over there. Let's suppose we have an e-commerce website, and each a good e-commerce website generates a terabytes of data per day, right? So these are the problem nowadays, because we have to collect a lot of data nowadays. Then after collecting it, we have to store. Now, as we all know, we have relational database, which is NoSQL, MySQL, Postgres, right? But these things are not good for storage a big data, right? Because companies are really having issue nowadays. They are getting a lot of data, like petabytes, terabytes. This is not just a thing nowadays. And the more the more years just finish up, so the data would be like tremendous amount of data we do have. And the management, what if after the collecting thing, after the storage thing, what to do, the management thing, right? So this is what data engineering is. And also, whenever a company change his technology stack, let's suppose a company has a database on MySQL, right? Now they are shifting towards Postgres. So the migration, right, the migration itself has the has comes into data engineering too, because a company wouldn't lose the data, right? So these are the beautiful stuff, a critical stuff that we are going to talk about in this educational podcast. So just spare with me, and we are really going to have fun, while just see what is data engineering, how we can build pipelines on cloud, and why data engineering is so important nowadays. Okay, so here's a very concise and a good diagram to show you what data engineer would do with like in the data engineering stuff. We have a lot of different, you can say, departments. Like some of people working with the data warehouse. And what is data warehouse? This is literally a very, you can say, a very interesting thing, because a lot of people mix data warehouses with databases management. But this that's a completely different thing, and I'm gonna clear your concept today. And some people work with integration. Then we have data modeling, analytics, and data pipelines. Okay, so data pipelines, data warehouses, we are going to cover. But let me just give you a short overview, a brief overview on what is data modeling. See, so let's say we have a lot of tables, more than 20, 30 tables. So these tables are not going to store alone. We have to make a model, so they are joining in some way. So if a person has a query, so that data joins a lot of tables, so it comes up in just a milliseconds. So for this kind of situation, we have to do data modeling, right? And it's a itself a big field, and it comes in the data engineering. Okay, now so data integration. The data integration is how you integrate the data into your pipeline. Okay, all right. And the analytics is a very famous. We usually do on Excel sheets, Google sheets. We love to make charts, make sums. Like everyone knows that. So this is what analytics is. But suppose we have 100 terabytes of data. Do we really can put on Excel? No, Excel is going to be crash. Can we put on Google Sheet? No, Google Sheet could not handle like more than GBs of data. So how you can store a terabytes? So that's why this is we are going to cover the how data engineering can store, and or how why data engineering is so swaggy, so he can just deal all of this with the big data stuff. Okay, so why data engineering is so important? As I've already told you that the efficient data management, because nowadays a mid-tier company can generate a lot of data that we can't store on premise, right? So we need an efficient data management, so data would manage, and it it would be very cost effective in terms of space, in terms of money, and also enhance the data quality, because a lot of people has data but in a very bad quality. And our machine learning engineers, our AI engineers would need a good quality of data, right? So we have to maintain a good quality of data for the AI engineer, for the machine learning engineers, and of course for the analytics, and also for the scalability. Because let's say if we just have a normal database system, that is not a scalable solution. um the the best thing we can do is we can just put our database on the cloud, but it is going to be stuck, or our cost is going to be very high. So that's why data engineering is very important, because we have to engineer, we have to apply engineering principles on the data, so data could be stored in a very, very, very good format. Also the accelerated analytics and insights, because our business stakeholders, CEOs, CTOs, definitely they have to see the progress within an hour, within a minute, or you can say after a day, right? So to speed up this performance, we have to accelerate our analytics and insights, right? And also supporting advanced technologies, because if we don't have a good data quality, how we can give a data to the open AI or Gemini, so they can give so they can improve their chatbots, right? So it's all about the good data quality, right? So okay, so I have a good, very good you can say a picture over here, which tells you like the step by step, like how what's the benefits of data engineering. And it tells you that data quality and consistency, right? The consistency means, suppose if your data flows system to system, so it should be the same. It doesn't like I'm like, my name is Abdullah and my age is like 22, so it should be the 22 in the end system too. All right, so this is the consistency that we have to make sure, and that's the job of the data engineer. And the real time data processing, and that is a very, you can say, an interesting thing. So just thought about how Uber or Cream, are cab services, how they are communicating with us with the real time data processing. They have a very, very, very good solution behind the stuff, so they can communicate with the users, and this is all because of real time data processing. In my country, Cream is not here, but still, the engineers of Cream in my country working for the UAE companies, for the UAE Kareem company, so they can build a scalable solution, real time data processing. So they have a so they can get a real time data. All right, and also improve decision making. As I've said, we have machine learning models over there, and we have some analysis reports over there. So we need data engineering for this, and the scalability, of course, and a better data governance, because data is very important. Data is the new gold. That is a new oil. So we don't take a chance to compromise on a security, right? So all of these things comes into the data engineering. Perfect. Now let's jump into the dilemma of data science versus data engineering. So I just took a very good diagram, a good a land you can say a picture that you can see where does the software engineer relies, where does the data engineer actually relies, and where does the data scientist actually take place in it. Okay, so here on the screen. Okay, so let's take a picture. Let's take an example of an e-commerce website, or you can say, okay, just let's take a Netflix. Okay, okay, so see, thus the Netflix software engineers have made a platform where we can see our favorite TV shows, movies, kind of something, right? So that platform built by the software engineers. All right. Now now we all know Netflix or kind of Amazon Prime, they are really efficient. Like, if we click on show, the next day or the next minute or the next hour, they are going to recommend a very efficient TV show, the one that we have just see before, right? So how this thing would work? The data engineer make a pipeline. Of course, what's the pipeline we are going to see as we move forward. So the data engineer make a pipeline, and that pipeline is so efficient, it just fetch the data from the Netflix. It process the data, comes into the models, machine learning models, and after the learning model runs, so they push back the data to the Netflix application, so we can have a recommendation, right? So this is how things works, so fast and so efficient. And who's the middle layer? The data engineer, right? So okay, so now let's see the diagram, and you can see the first part. Let's say we have a three parts, and the first part covers with the software engineer, where our engineers or software developer are going to make our product like a Netflix. Then we have a middle layer, which is a data engineer layer. What data engineer do? They make data standardization, denormalization, data modeling stuff. They make pipeline, right? So they can fetch data, they can store data efficiently from Netflix, because Netflix can generate a lot of data, even a per minute, right? So a software engineer cannot do that. So there's a special team required, which is called data engineer, right? After it, after it, there's another layer which comes after the data engineer, which is we call data scientist or data analyst. Okay, so now you have seen that data engineer is solely responsible to manage the data, or to make pipelines, right? Or to, you can say, or to secure the data. They are just responsible to pull the data, store the data, and push back to another layer, and that is layer called data scientist, data analyst. That could be AI engineers, that could be machine learning engineers, right? So let's take an example what data scientists would do. So when data engineer fetch data from the Netflix side, data scientist would apply a model, right? You can say a user churn model, or a screen time model. How what's the screen time of the user, what a season I should recommend. So that's kind of stuff, because I'm very weak at the machine learning things, so please don't judge me. So this these are the models, and the models needs the data, right? So where they are getting from data, where from the data engineers are making their data. All right. And also data analysts are solely responsible to making analytical pipeline. They are responsible to making insights, so they can show or they can take decision immediately, right? So data engineer is responsible to making so to make all of the data in the between of software engineer or analyst or data scientist. Then they give that data to scientists, engineers, AI engineers, analysts, or machine learning engineers, etc. And in all of the things that we have a product manager who decided which team is going to be work on what role. Okay, all right. I think this is the I think now the dilemma shouldn't be affected. Like, what's the data science and what the data engineering? It is literally, there's a lot of difference between them. Data scientists are really work with the science kind of thing, mathematical things, model things, right? But data engineers are very close to software engineers, because a lot of principles are related to software engineers, and we have to work all of the rule and regulation kind of very similar to software engineers, but we are only responsible to work on the data. Okay, all right, perfect. Now, what is an ETL pipeline? This is what this is talk about is, right? So I just add a simple and perfect image where you can see what is the ETL pipeline. As I've already disclosed that ETL is E for extract, T for transform, L for load. So what is extract? Suppose we have a software, or we have an application, a web application, right? So it generates a lot of data, or 2 gigabytes data per minute. So we have to make a pipeline who can extract data from that app. All right. So this is what's complete the extraction. Definitely there are a lot of layers come into the extraction layer, but this is what it is, right? So this is the whole purpose of the extraction layer. Then comes into the transform. So what's a transform is? What do you think? When we are fetching the data, or when we are extracting the data is not in a good format. Data is very a buzzy, very fizzy. We got a lot of zero, we not have a good formatting, we got a lot of duplicates, right? So the transform layer is only responsible to make data clean, the clean. And also, each business has its own understanding, each business has its own logic. So the transformation layer would highly depends on the business logic. Like, let's say I have a date column, and whenever the data is going to be extracted, the date isn't match the format what my organization usually do. So we have to reformat the date. Also, let's say we have a lot of duplicate values in it, and we have to see, and we have to remove the duplicacy in the data, right? Also, in the transformation, in the transformation layer, we can see that if there are null values or not. If there are a lot of null values and our system doesn't require that, so we have to remove them, or we have to add in something average, so we can test our data or test our system. So this is all the responsibilities comes into a transformation layer. All right. Then comes into the load. So the load is uh, all the ETL pipelines, all the data engineering pipeline has only one purpose: to load into a data warehouse or a data lake house, right? And some of them are put them into the relational databases system. So load can be any storage system. It could be S3 file system, it could be Azure blob storage, it could be Google storage, any kind of system. So this is what we are going to do. First, we are going to extract the bad data, then we are going to transform into the very, and we are going to make a very beautiful and good data according to our business need. Then we are push that data into some storage services. All right. So this is what ETL pipeline is. Not a big science, not a rocket science. All right, let's come to in the pipelines paradigm. So basically, this two pipeline nowadays. The ancient one, the old one was the ETL. Still, a lot of people, a lot of companies, work with the paradigm, the ETL. They are extracting data, they are transforming and then load. But nowadays, when all of these pipelines comes into the cloud, they are going to make the ELT. So what's the ELT? There's a slight difference between ETL and ELT. As you can see, ETL is equal to extract, transform, and load, and ELT is equal to extract, load, and then transform. Right. So how what ELT works? Like, ELT extract the data. Let's suppose we have an S3 bucket. Okay, and we have an extraction. We are doing airflow, or we are um, just performing a lambda function to extract the data from anywhere. The source could be anything, a software application or API or something, right? We are fetching data, but first we are going to load into the S3 bucket, right? Then after we have another extraction layer, and that is going to be fetched, and then we are going to put that into the transform layer, right? And then definitely, there's a load system. We have a lake house, warehouses, and the list goes on, right? So but this is a basic concept. When we are going to extract, then first we are going to load, then we are going to transformation, because nowadays data is really big, really really big, right? So we can't do just extraction and just apply transformation. Data is really big nowadays, so we have to uh, select a paradigm of ELT. All right. Okay, so here's a very good example. So how ETL works and how ELT works. So it's a very simple. Extract it in ETL. We are extracting data from sources. Maybe it's a log services, a CRM or ERP system. We are we are The moment we are getting data, we are transforming it, right? Simultaneously, and we are then load into the data warehouse. But in ELT, there's a different case. We are extracting data, then we are going to load first. Maybe it's a warehouse or maybe it's a data lake. Then we are going to transform, and after the transformation we are going to load that data back into data warehouse, right? So this is how the paradigm work. And nowadays there are really good architecture called Medallion architecture. Unfortunately, I haven't put in my slides, but I really want you to search the Medallion architecture. Like this silver there's a concept of bronze layer, silver layer, and golden layer, that we are whenever you are going to extract the data, you are going to put in the bronze layer. Then after loading into the bronze layer, you are going to extract data, transform the data, then you are going to put in the that clean data in the silver layer. After the silver layer, you are going to make another layer which called the bronze layer, which called the gold layer, and in that layer you are going to make your SQL models, your queries, your machine learning models kind of data, right? So what are these bronze, silver? These are just the S3 buckets, or you can say an Azure storage services, right? So these are just a naming convention to understand. Yes, so this is the middle architecture. All right. So what we do have now? Okay. So building ETL in the cloud, conceptual workflow. So why we are going to make our pipeline on the cloud? That's the main question. Why I'm forcing into, why people are forcing, like why a lot of companies now heading it into, like why how things work, like why things were not working on premises, why we should use cloud to make our ETL. Okay, a simple answer. A cloud native advantages are the scalable solution, because on premise we have a really big disadvantage is we have to, you can say, increase our servers. In fact, we have to hire a person who's a server expert. We have to maintain a room who got a good air conditioning stuff. That was an old days. So nowadays, just people just start using cloud. They have some space, and they just provide a good scalable solution, and also cost effective, and also a serverless, and all the cloud, and we can't have that taste in the on-premises thing. So that's why building ETL in the cloud has that concept. So that's why ETL on the cloud has a great, you can say, workflow on it. Also, the other thing, the layers of cloud ETL. If you have remember, I have just mentioned the bronze layer, the silver layer, and the gold layer, right? So this is what we use: the raw layer, the process layer, and the curated and or the presentation layer. So basically, raw layer is the bronze layer. We have where we have get the bad data, a very of very, you can say, a fuzzy data that a human cannot understand, even a human cannot analyze after performing calculations on it. Then but we are going to do the process layer. We are going to process that data, and after this whole process, we get the data very clean. Then after that clean data, we are going to make a presentation on it, right? So what our business needs, what our stakeholders need, we are going to make that. Okay, now we have a great comparison, like um, what's the difference between if we make our ETL on premises, and what's the difference between if we are going to make our ETL on cloud. So first is infrastructure, right? So this is a very self-explanatory thing that if you are going to make on-prem, so we really need require physical servers and a manual setup. So suppose you are getting data, 100 terabytes of data per week. Do you really think that you can just set up a server in your home or in your office, who's going to be, who's going to be stay there like after 5 years? No, this that server is going to be crash after a few years, like 2 or 3, right? Because the data is going to be bigger and bigger. Nowadays we have a lot of data, so that's not a good, you can say, unless you have a very sensitive information, very, you can say, a government body, so you can't take the cloud for your solution. So then there's then there's a case, a different case. But if you are working for a company who really need a scalable solution, who cannot invest in the physical and manual setup, then cloud is a good solution for you. Because in the cloud you can have a pre-built services over there, where you can make an ETL pipeline and fully manage the cloud provider like serverless or option available. Also, the point to the scalability, limited in the on-premise, we have to limit it by hardware capacity. Because um, you've already know that in the server system, in the old days, we really need to hire people, some expert, and increasing again and again our capacity, right? But in the cloud we don't need this. This is going to be auto scale based on our data volume, right? If you just take an example of RDS on Amazon, AWS RDS, this has a capability of auto scale rather than the serverless, right? The serverless is another a good thing, but we also have a auto scale, you can say, thing. And we just have to click some few option and our storage is going to be increased, rather than we are going to go market and we have to see some vendors, then we implement it. It took a lot of time. Then the cost, obviously, there's a very high upfront investment. And the in the cloud we just have to pay as you go, right? And also the maintenance needs manual upgrade and monitoring if we are going to make a ETL pipeline on prem. And if we have set up on cloud, but the cloud handles the update, the scaling, and the reliability, because we don't have to update our system again and again. This is all the headache is comes with the cloud vendors. Then definitely we have a speed and flexibility. On prem, let's say we have a very slow server, or we have a very compact server, how we can increase speed, how we can do the flexible? No, there's no thing, right? So slow setup and rigid resources, that we can't try different things. If we have to try, then we have to do, then we have to implement thing by physical thing. So that's a very long process to increasing the speed on prem. But if you are going on cloud, then there's a quick development. As I've already mentioned, you just have to click some option. After clicking on them, your, you can say, your speed is going to be like 2x, or also your price is going to be 2x. But the speed is going to be high in your just few clicks. All right. So that is how, that's a great comparison, why you should make on prem or why you should make cloud. But still, nowadays people usually prefer on-prem thing, because again, the data is sensitive, data should be secure. A lot of banking sector category, they usually prefer put that data in their on-prem system, in their local setup. So this is how things work. But the companies, a lot of companies relies on cloud. And why I'm mentioning AWS again and again, because AWS has the great market share, like around 33 to 35%. So people are really familiar with the AWS. Okay. So that's how I just give an example. So maybe in the audience you can just catch, hey, yeah, I raised that thing. So okay, perfect. Now we have an AWS ETL architecture. So, as we have seen that we have to make a pipeline, right? But there are two types of pipeline. One is stream process pipeline, that you have seen in my in the current slide. So basically, stream process pipeline is a real time pipeline. Just again, you recall the example of Uber and Cream, the cab services, right? So how they are, they so efficiently connecting with us, because there are data engineers, are very good data engineers, making a real time pipeline. So whenever you just click a button on it, it gives the request to a rider or a cab driver or a captain. Then you can just see the location and all of the stuff in just a few seconds, not a few seconds, within a second, right? So this is how you can make stream processing pipeline, because it's a real time pipeline. Whenever event occurs, so our pipeline would run, and the there is no latency in it, in the real time processing, or you can say a stream processing pipeline. And if you're talking about on how we can do on AWS cloud, so I have a great architecture over for you. So let's say Kafka. So what's a Kafka basically? Kafka is an open source by Apache, which is useful for for the real time processing, and for processing a data, because we can't just use Python, because Python has a pandas library, but it's a very, it took a lot of load. Pandas cannot handle that much data. So we need data processing frameworks like Spark, like Hadoop, so we can make our system better, make our data processing more efficient way. So that's why we need Kafka. Kafka is for real time processing. And we have some stream data source available, let's say there's a file storage system or RDMS. They are fetching, so Kafka is fetching from the stream data source, then Kafka push that data into the AWS glue. So what's the AWS glue now? So AWS glue is a platform or a service by AWS, which is a complete suitcase where you can make our your ETL pipeline. Just go on AWS glue. You can see there are three options. You can make notebooks, Python notebooks, and also you can make by visualization ETL pipeline by UI. And but that that costs you a lot. And also you can just write a simple Python script, and that will cost you very less. And also you can write big data processing framework, and AWS glue does support Spark behind it. All right. And maybe you have thought like, what's the glue data catalog system? So basically what data catalog is, it stores the metadata of your data. All right. So then again, the same extraction, we are extracting data from AWS glue, then we are transforming the script, and we are going to load that data in our AWS S3, right? S3 bucket. So so we can use later in every manner, or every everywhere also. So what we have two paradigms for the pipeline. One is stream processing pipeline, which is a real time one, and the other is the batch processing. So batch processing pipeline do have a latency. So suppose in the previous real time processing, we just took an example for the Kareem and Uber, and that does make sense, right? Because how you can it looks very weird that you just request and you got the response after 3 minutes or 4 minutes, right? So that's not a feasible solution. But in the batch processing pipeline, if you have thought that you have an e-commerce company and you are going to run your pipeline after 6 hours, right? So your or you can say I'm going to run my pipeline after the working hours. So if my stakeholders can open that insight stuff, so they can just open any time in the morning or in the late night, so they can see the result, right? So that's how we can expect the latency in the batch processing. And these are the very beautiful services given by the AWS. I'm going to introduce one by one. So first we have a very popular service, S3 bucket. So we can just easily store anything on this bucket. And then we have lambda function. So the lambda function is like where you can just put your function on any language like Python. It has a JavaScript, right? So lambda function has only one, you can say, limitation. It can only run for the 10 minutes, right? And it's a serverless thing, but it has only very less capability to run. Then we have step function. So the step function is the orchestration. So what's the orchestration tool? So let's say we have a very big pipeline, right? So that pipeline has should something to be managed, right? So step function is a service of by AWS, who are going to manage all of these services, which is in a box like after the third stage. So step function can orchestrate orchestrate a new lambda function, that lambda function put that data again into S3 bucket. Then we have Amazon SNS, which is a success or error notification. Again, then we are again, if you have focused on the AWS lambda validate CSV file, then we have Amazon S3 stage folder. So this stage folder is you can took as a bronze layer, our raw layer, right? So we have a raw layer here, and then we are going to run our crawler, so crawler can fetch that data and put that data into the AWS glue. All right, and AWS glue then is transforming that data according to the business logic. After transforming it, it pushed that data into the transform folder, you can say a silver folder. And the file would be changed into the parquet format, because let's say if you are going to save that file in the CSV, right? So CSV is not a scalable solution, because CSV store data in row by row. But if you are going to store our file in the Parquet format, so it is going to be stored column by column, and which is a highly efficient way to fetch the data from. So that's why AWS3 is a very good storage. So this is how we are going to store. Then you can see we have another crawler, and that crawler is responsible to transform that file, create schema and from transform file. And that crawler fetch, you can say, and extract the data, not extract by the way, push the data into the AWS Athena, so people can do the ad hoc query. So what is the ad hoc query? So it's a real time thing. Let's say a business person comes me, hey Abdullah, what's the sale of after the previous hour? So I can just write some SQL statement, and I can show them, hey, so this is the progress. So also apart from this, we have an in Amazon S3 archive folder or error folder, whatever the error so we can we can have them into the another S3 storage. So, and this pipeline can be run after an hour, after a few minutes, after 10 minutes, after 15 minutes, or after a day, right? So that's the beauty of batch processing pipeline. So we don't have to run pipeline in the real time. We can just set up a time. Let's say there's file comes into the Amazon S3, and then we are going to run this pipeline. Let's say our file comes after the intervals of 2 hours, no problem. Whenever the files come in S3, so we can orchestrate all of this pipeline, and it is going to be run, right? So these are the services offered by AWS. So I would love to tell you just do some hands-on, see what each thing are going to be work, how this is going to be work, right? So this is very important. Okay, so now my favorite thing, like what are the data warehouses? And it's a very good knowledge for everyone who still think that data engineers store data in the relational database system. And that's a completely false statement, that we are not going to store our data in a relational database system. We are fetching data from them from there, but we are storing on data warehouses. Okay, now the question is, what is data warehouse then, right? So that isn't the data warehouse is the same thing like databases? No, they're completely different, because a data warehouse is a central, you can say, a system for storing and analyzing historical records. So let's see steps one by one. So what's the purpose, by the way? For the relational database management system, the purpose is designed for day-to-day transaction operations. So what are the transaction operations? Let's say we have the data is just comes in, and we have a very let's say people deposit something into bank, so the data is going to be reflected in his table. So this is what transaction mean, right? And in the let's see if we are going to see in the data warehouses, right? So the purpose is really different, because that is designed for analytics, reporting, and decision making. Might possible you have thought, what is OLTP then? What is OLAP then? So OLTP means online transaction process or protocol, right? And OLAP is online analytical process. All right. So that is how AWS sorry, the data warehouses are completely different kind of thing with respect to RDMS, right? Also, one thing, what's the data type? Okay, so data type in the RDMS we have current, detailed, real time transaction data, right? So in the RDS we can make models, we can do the stuff like analyzing etc, but that is going to be so slow. Honestly, that is going to be so slow, because let's say a banking management system has 200 terabytes of data, and you are going to just query. It will take like an hour to fetch the data, and how about your query would be wrong, right? So that's why we need historical, aggregated, and analytical data thing in the data warehouse. So that's why there's another 0 2 points for the data warehouse. Like data warehouse has a capability to get the aggregate the data and store it. Okay, now the data structure. So in the RDS we have to normalize the data, like we have to make multiple tables, we have to make joins with them, right? But in the data warehouse we have to be very denormalized data, because we have to break that normalized thing, and we have to do the data into the very thing, so we can make some models, SQL models, query models, so our dashboards can reflect, our analysts can see. Also, what's the use case? Again, banking, e-commerce, and ERP system, they are would love to use a relation database based management system. Okay, so when I say they would love to use them, that doesn't mean that they have only RDMS. No, they should, or they have like database houses, but for the transaction they just use RDM, relation database management system. Okay, and let's say let's come to the use case of the data warehouses. How data warehouses comes into the real life. So the business intelligence dashboard, trend analysis, right? So let's say again we have a big data, a lot of terabyte data. How we can aggregate data again and again, because sometimes data wouldn't be right that much efficient. So we have to make models before rather than we are querying again and again. Right. And let's comes into the examples. So MySQL, Postgre, and SQL Server are the great and legendary example for the relational database management system. And for the data warehouse, definitely we have a lot of data warehouses there. We have Snowflake, we have Azure Synapse over there. But in terms of AWS, we have Amazon Redshift. Okay, so this is how the Redshift would look like. So let's say we have just fetch the data from the S3 bucket. We put the data into a AWS Glue catalog. Then we have Redshift Spectrum. Then our data, um, go to the Amazon Redshift. So Amazon Redshift is a solely service from AWS, which is responsible for the data warehousing concept. Also, one thing which is a very very important point, maybe if you are given an interview, so they love that question. So what they ask, what's the architecture different between RDBMS and the data warehouse, right? So one thing you can answer: relational database management system are storing data row by row, right, in a table format. But in the data warehouses, data is going to be stored column by column. So that's why this is really easy to process data much faster in the data warehouses. All right. Okay, so this is pretty much it, and I think I just do a lot of yap. So now, and thank you so much again, guys, for listening me, and just you're welcome to ask any question, answer, and over to you, Damien.
That was a lot of information. I was reliving my Microsoft certification as you went through everything.
Yeah,
Yeah. But I don't think that I knew that that was the main difference between a data warehouse and a relational database management system. I don't know how
yeah,
I forgot that, but that is actually really interesting to do it by column instead of by row.
hmm,
Um, so in your experience, is there a public cloud provider that you find to be easier to work with versus another? I know that you might be a little bit biased because of your AWS
Yeah.
relationship, but have you done work with Google or Azure in
Yeah.
that regard?
Yeah. Okay. So I'm going to be very honest with this answer, because a lot of people, have think that cloud is which cloud we should focus on,
Hmm.
which cloud we should work first. So this is a very common question among anyone, right? So I started my journey with Azure, and honestly, Azure has a very good user experience and user interface, and I still literally work love to work with Azure, because of their UI experience and their management skills. But while learning Azure, I spent 30 days, right? I spent 30 days to just understand how things work, behind the stuff. But when I shifted, when I just just I just you can say hired by someone, and they're working on AWS. So it just took me like 5 days to just completely shift it to the AWS, because
Mm.
things are working the same in the background. So I would say just pick a cloud, and doesn't matter which cloud is it, whether it's GCP, whether it's Azure, whether it's AWS, just work on it. And whenever there's a thing of the shifting the thing, then there will be no difficulty on it. It's like when you learn C++ language, then it's easy to learn Python, JavaScript,
Right,
and all
right.
everything else. Yeah.
Yeah, yeah, because those are all derived from C. Yeah.
Yeah.
So there's a question from the audience, from Abiola, and the question is, if I want to call my Postgres database once a day, have the data cached, and I don't want to call my database again, but use the cache, what's the best way to cache that data in your experience?
Okay, so if you are working with the Postgres, so I would love to tell you that use the materialized views, right? Materialized views are something that this is not going to cost you a lot, and this is not going to compute again and again, right? So this is going to be put very less load on it. Since you're working with Postgres, so this is an opportunity for you. Make materialized views, so they has a so how this would be work like. So whenever you are going to make materialized views, so it will pre-computed your data over there, right? So whenever you are going to call it, so it's not going to again run the server or just computation stuff. This has already the pre-computed results over there, so you can get the results from there. Yep.
Okay, awesome. Well, thank you. Um, I'm not seeing any other questions. I know that we this time for us is quite early. So you know,
Okay.
we don't always know who's going to be joining us live or not. But I'm not. Let me
Yeah.
check over here on Blue Sky and also on LinkedIn. But yeah, I'm not really seeing a lot of questions here. Where can folks
Hmm.
find you if they want to reach out to you to talk more about this?
Sure. They can find me on LinkedIn, and also they can follow me on just LinkedIn, and also I have my YouTube channel. So when this educational podcast is going to be live on YouTube, I hope so that this recording is going to be uploaded on YouTube.
Hmm.
So you can just mention link on the description. So you can so my name is M. Abdullah Bin Aftab. So it's I know it's a pretty difficult name to pronounce, but yeah, I forgot to put my barcode over there. Honestly, yeah, I should put over there. But yeah, you
Yeah.
can just give the link. Just do me a
Okay.
favor.
Yeah. Yeah. Awesome. Would you mind emailing me your YouTube channel? And I
Sure,
will put your LinkedIn and YouTube channel in the show notes
sure,
when this is republished. All right.
would
Well,
love to.
yes, yes, thank you. Thank you very much for coming on the show, Abdullah. This has been very informative, and I really hope that anyone else who's interested in this, can use this as an opportunity to learn more and to really dig into the cloud of their choice. And so, thank you for all that you do. Thank you for your work in the community in Pakistan. I think that's amazing. It's really cool to see, all the different parts of the world as they kind of come online, right? And I know
Hmm.
Pakistan has been moving toward that for a long time, and that's
Yeah,
it's fascinating. It really is. So, thank you very
yeah.
much for your time, and yeah, with that, we can go ahead and end the show. So, thank you.
Thank you so much. I mean, it means a lot, and It's been great. Thank you so much.
Yes, sir. Thank
Sure,
you.
sure, sure. Bye bye, everyone.